It seems to me like the biggest culprit in making things difficult, resistant to change, is things that are coupled. No, you're shaking your head.
It's people.
Hey, everybody. Welcome to the latest edition of How Many CTOs Does It Take? My name is Scott Porad. I'm here with my trusty co-host,
Brad Hefta-Gaub.
And today our guest is John Helm. John is someone that I've worked with for a long time and known for a long time. And, John, how would you like me to introduce you? I think you've done a lot of things and I'm not even sure where to start.
Well, I guess a productive way to do it would be to point out that I've made a lot of mistakes. I've learned from them. And the ruler I use to measure success with is not repeating mistakes and not doing mistakes that are obvious in the first place and should be avoided. So I've done a little of each, unfortunately, but I think on balance, maybe I've learned from all of them and only repeated a few. So I can try to share some of the things I've learned so your audience can make original mistakes.
That's the idea. Let's all make original mistakes. I like it.
Yeah,
Perfect.
that's the best you can ask for. Non-fatal original mistakes that you can walk away from and be smarter or wiser or kinder.
Yeah.
Well, our industry makes a semi-fatal, non-original mistake all the time. And that is the ball of mud. Spaghetti code, tech debt, whatever you want to call it. We dig these holes that are so deep that they are impossible to get out of. And that's what I'm hoping we can talk about today. Tech debt. How do you measure it? How do you prevent it? How do you fix it? How do you teach people to not make the same mistakes over again? How do you tell business people and customers the value of it? Either the cost that it's causing you or the benefit of avoiding it or the benefit of getting rid of it, all these different things. And John, I know this is something that you have thought about a ton, you've studied a ton, and let's just take some of those questions and unpack them. I'd love to know what your thoughts are on this topic.
Sure.
Where do you want to start?
The mischief begins defining tech debt. So one person's tech debt may not be another person's tech debt. And often there's a time frame involved. If you're a very senior executive with an equity package, your time horizon may be much shorter than the lifetime of the software that's created on your watch. And in fact, there may even be on occasion a conflict of interest where actually avoiding tech debt might affect the valuation of your package. And so if you're optimizing for your package, there's actually a bit of a conflict of interest between them and managing tech debt. And that's assuming that everyone agrees on exactly what tech debt is. Another aspect of this is some people think a little tech debt is fine, right? There are people, let's say you have a fleet of delivery vehicles and you're supposed to change the oil every 5,000 miles. Some people do it assiduously and other people never do it. And they say, we'll just run it to the ground and get a new one. And so their relationship with the risk profile associated with their perception of tech debt, which in the case of vehicles often can be accurate, plays into this posturing of how important it is to do something about it. And the problem that we have as CTOs is we often have to live with consequences, or put another way, I think we turn over less frequently than CEOs. So we get to live with the halo cast as the shadow perhaps cast as the CEO that was like at one place we worked together runs off, with the prestige and the fingers up in the air, waving the V sign. And we're left with this pile of poo, wondering how the hell we're going to pass the next SOX audit. So there's this dimension, and it gets to I don't want to start lecturing, you interrupt me with questions, but I think it's a very important fundamental principle that I have learned, which may even be true, which is tech debt is not a technical problem. It's a technical symptom, and it's a symptom of underlying causes usually far from the source of the symptoms. And it has to be because people use the word technology in a sense to mean tools, but it comes from, it's a Greek word, and it means the applied understanding, and there are three parts. Maybe four. There's a value you want to accomplish. That's usually outside of it, but then you need a means by which you accomplish that value. We'll call that a process. And that process is enabled, and people have to learn the process, right? Processes are inanimate. So we make decisions, we choose the process, and then we choose how to implement the process. Almost all processes these days require tools, which we often just call technology, that create the conditions or somehow enable the process to occur. Like if you're a glass blower, pretty hard to blow glass unless you got a ladle full of molten glass and your blow pipes and your marving table and all that stuff, right? So and you choose your tools, and you can choose the wrong tools, or you can choose tools because some salesperson takes you to steakhouses and runs up a big bill, and you feel this deep need, this deep psychological need, which is called reciprocity, to buy the poo because you've eaten all the steaks and drunk all the $1,000 bottles of wine. It's not a technical decision at all, is it? But that's how the poo shows up. And then CTOs got to make it all work.
Yeah.
So the first problem with tech debt is getting everyone to agree on what it is, in my opinion. And the second, I think, point we've made is tech debt is a human problem. It's decisions made by people with beliefs about the world. There's and not everyone has the same beliefs about the world, right? There's this concept called plural rationality. You look at a resource in the ground and you can say it's finite, we must conserve it. That's one view of the world. Or we can say use it up because we'll innovate again and need another resource later. There's evidence of both, right? One of the reasons why there's so much coal in the world is we never ran out before we switched to oil. But there are people that want to conserve other resources, and there's no right answer. It's kind of, we make leaps of faith, and then the best we can do is be rational from those leaps of faith. So you make leaps of faith about the technology you buy, how it's going to work, how long it's going to work before you take the money and run. And CTOs are sort of stuck between the boat and the dock with those decisions letting out the line.
John, what do you think about? I'm kind of curious what your perspective of like the idea that software, like any kind of capital, depreciates over time, and is that is that a reasonable way for us to sort of think about tech debt
No,
depreciation?
software does depreciate, but I don't believe it's a reasonable way to think about tech debt. It depreciates because the value, it's just like a physical asset, right? The reason why depreciation exists is so that you can set money aside to replace the asset when it wears out. Software doesn't really wear out, but its utility, its aptness for the market diminishes over time. So in fact, it wears out in terms of its relevance, even though the parts really don't wear out, or they wear out so slowly that we can ignore it. So in that sense, it does depreciate it. But there's a second bit of mischief here. I think that's fair to surface, which is the notion of debt is a financial one, and often is considered a tool of management, right? If you're not adequately leveraged, you're leaving money on the table. So a lot of people will assume debt to create, let's say, a larger means of production. And as long as they're correct, the increased revenue from that increase in capacity will service the debt till you pay it down, and you've grown, and you might not have been able to, or buy a house. None of us can buy a house without, well, at least none of us on the call can buy a house without getting a mortgage first. So it's actually a concept where there's several factors are in place. First of all, what it is well defined, right? It's cash. It's a unit of account, and maybe its purchasing value goes up and down. But when you borrow X dollars, you are on the hook to give X dollars back. There's no discussion about is that dollar the right color, right? They're dollars. So we've defined what the asset is. Then we can price the risk, right? That's the interest that we agree borrowing that money is worth. So that's the cost of the money, and so you can price the risk. The next thing is you can create an agreement that's mutually understood and enforceable, which is your loan agreement. And so all the parties involved understand the cost of borrowing or the cost of lending and the risk associated it. So it's kind of a, I won't say it's a rational decision, but it's a well understood, repeatable decision from which years and years of experience doing it gives us this intuitive understanding. And if you learn the mathematics of the time value of money, you can actually model it. You can play games with the depreciate, the return on the interest rate curve, like you can front load it like they do with car rates, but everybody can figure out the game. And when you write software, it's a lot more complicated than just borrowing money and paying it back somehow. So I think that some people think that when we use the word debt in our mind, it doesn't sound so sinister, um, because we have we're living in a house that we borrowed money to get, and
Right.
we know that if if we spend more than we make and we run our credit cards up, it can be sad, but we know, right? And in technology, maybe we'll get to it in a little bit, but I've actually modeled it as options where there's things called puts and calls, and and I think you're actually writing software on margin. And puts and calls are notorious for causing mischief with naive investors, and very quickly, maybe running ahead a little bit. Um, Puts and calls on things like stocks are each one's independent of the other. And while if you sell naked calls, you're exposing yourself to a lot of risk. They have an expiration date and they don't interact. But if you're writing software on margin and the margin is cutting the corners, one, the option never expires until you retire the code base, and we know how often that happens.
Right.
And two, technical debt can interact, right?
Yeah.
So the value of that, let's say it's just on margin, you're not doing a naked call, but you're selling a call on margin. You don't have the whole asset, right? Because a call is, I have some stock and I'm going to sell you the right to buy it at a certain price over a certain time, right? And I may not have all that stock, and the difference is called margin. And if I have none of the stock, I'm just so confident that the price of the stock is going to go down, and I'm just going to take your money when I sell you that call. That I don't have any of it. And that's called a naked call. So, like, if we sold software and never wrote it, it'd be naked. Or if we maybe more realistically write some throwaway code and think we're going to walk and never see it again, well, then it is almost a naked call,
Yeah.
unless in fact you're wrong. But the point is so the debt concept can lead us to oversimplified thinking or maybe overconfident thinking, and the if we accumulate several of these quote unquote investment instruments, they're not independent of each other. We don't know the expiration date and they can interact. So we actually don't know the downside because we don't know what the interactions are until it happens.
Yeah. So almost like I almost hear you saying that the fact that we start by calling it tech debt already leads us down the road of thinking about this incorrectly. And if we called
That
it naked calls, selling tech naked calls, then we might be a little bit more thoughtful about the choices that we're making.
Yes, and in fact, that's one of those lessons from experience I'm trying not to repeat. Is I say, "Oh, we can take on a little tech debt to make the deadline, right?" And came back and hurt.
Yeah.
So yeah, and it's not, it's a model that helps us think about tech debt differently. I wouldn't. I have tried to monetize it, and one of the things that CTOs have a difficult time doing is arguing the business value of what we do, because often if you do it well, or architecture is even worse. I happen to be old enough to think architecture is a useful exercise, but the attribution of the benefit of architecture is several steps removed from the cost of performing that architecture. And then the second thing is, if you do a good job, nothing bad happens. And I'll never
Right.
forget, I was on Wall Street at the time, and we were doing Y2K, and we're killing ourselves. And we created the Indian outsourcing business at the time because we couldn't get it all done on our own, and they were there to help. And Nothing happened. And later on, one of my bosses came to me and said, "Why we spent all this money on Y2K?" nothing happened.
It didn't seem like a big deal.
Yeah. So, there's a lot of behavioral economics in our job. So jumping back, I tried to figure out the business consequences of various technology decisions by modeling things like a project can be modeled as a bond, right? A bond is you put down a bunch of money and you get a contract that obligates the bondholder to give you a set of cash flows in the future. And when you do a software project, it's because a product manager is going to kill the market with this new feature and there are going to be cash flows involved. And you put a bunch of cash down and you start doing the work. And if all goes well, the coupons are realized according to the payment schedule. But then you can start doing things like, well, what happens if the project, so you can model the cash flows of the project. Say this feature will go on in 18 months, this feature will go on in 24 months, this one will go on in 36 months. Then you can start saying, what if it's delayed? What if it costs too much? How does it affect the yield of that bond? How does it affect its net present value? So I did a whole bunch of this work. And I think Scott's actually been subjected to some of it. And I was like, okay, now I can go talk to the business using their language. The models work pretty well, but they didn't work well in terms of an instrument of understanding. It was technical, it was involved. These were not in Wall Street institutional money managers, so they just wanted the answer. They wanted the elevator pitch, and if not, well, you're up. And so I learned a lot by that, but I also learned that monetizing the cost of software projects especially, and tangent, there's actually on Wall Street a way to compare returns on investments doing risk adjustment. It's called risk adjusted return analysis. The statistic is called M squared, or it's called RAP. And I have a deck that I know Scott has been subjected to, where I compared software projects up to about 2007 with grade B junk bonds.
Mm-hmm.
And the software projects were 7 times riskier. So the conclusion was we should never do software projects and take the money and buy bonds, junk bonds with them.
We'll get a better return.
Yeah, so that made me very popular as well. But I think this isn't the basis of a decision, but I think it's a whole dimension of decision analysis that technologists could take advantage of, and maybe it would help sometimes, or if nothing else, it kind of gives you a different vantage point to watch a project and maybe worry about different things sooner that would help prevent it from getting off the rails because you're not caught surprised that, oh, how did this happen?
Yeah.
And
John,
sorry.
Let me ask you a question here. So one of the things I hear you hinting at, and Scott and I have talked about this a fair amount, is that often it feels like the non-technical business owners, or our stakeholders that are we're trying to do this business with, they seem to express to us, look, I don't understand what you're saying. I don't understand why you're saying this is so important, or why you're saying that this particular investment is a make or break investment. And I love that you're talking about trying to use other ways to model it and to explain it hopefully in language that they would understand. But it sounds like even then they sort of just say like, wait, can you just boil it down? Yes or no? Do we do this? Yes or no? What, do you have any, I guess, and do you have any advice on the question of how do you bridge that language of the non-technical business owners just like, hey, look, I think my customers need this thing. They want this thing. Can't you just build it, John? Why are you saying it's hard to build this?
Yeah, there's 2 parts to that question. One is creating the audience, right? And if you ever heard of Richard Cialdini, he wrote a book called Influence. It's basically you have to figure out the right packaging to get the importance of what you're trying to share translated into something that's important for your audience, something they value. And they value the outcomes. And a lot of times, look, when you're a senior executive, you're way overcommitted. There's lots of risk. Some people, have different relationships with risk, and sometimes and if you get too burned out, you just don't, even if you might say, oh, that's interesting, but I don't have time for it. So you kind of have to find a way to sell it. And it's not a rational exercise, which I always thought was terribly unfair. But we're emotional beings as well as rational beings at times. And if you always come in with the cold calculus of reason, and you're dealing, especially a lot of CEOs don't have the technical background that we have to do our craft, to apply our craft. You're dead from the get-go. So then they want the elevator pitch. The second thing is, and I've gotten it pretty short, you need to make the connection between the difference in the activities that you're advocating and how it connects to financial consequences. And that gets back to what Scott was quite interested in about, which is measuring it. And there are a few ways to measure it. So if you want to segue into measuring a little bit, it informs your question, because you have to come up with ways where the units of measure can be unpacked by your audience, not by the people doing the work. So the metrics problem is tricky, because the metric has to, and the metrics motivate behavior, and good ones are the basis of a decision. And that decision has to be understood by the funders and actionable by the crafters, right? And those are hard. And what I was trying to do is connect it with money. And the connection with money and technical debt is, how does it manifest itself in ways that change the bond arithmetic of your software project? And I would argue there are kind of three principal ones. And essentially, the things that create delay, or things that cause you to be unsuccessful at meeting the commitments you set. And it boils down to really complexity and dependencies. And what happens with the complexity, and we can measure it. There's things like cyclomatic complexity and lots of things. And some people, they can be controversial, but they're proxies for the real problem, which is you go into a code unit and you have to understand it well enough to fix it without making things worse. And so complexity can be, it's a monolith, right? There's a big giant pile of Django and everything's all connected, or there can be giant baskets of, back in the day of my MFCs, or the different versions of the MFCs had to be linked in the right way, and you had to do incantations and have a compass that pointed to the center of the galaxy, which there happens to be one now. It's called the Galactic Compass. I highly recommend it. So you'll always be grounded. But so complexity slows people down, and it makes it easier to make mistakes. Mistakes don't get caught till testing. They're more expensive then, and such. So it's not even, do I have the right requirements and are they testable? We all know that that's just a pipe dream. You have to, and the intent of the Agile movement, maybe not what it's become, has been to take those things in stride and continuously manage expectations so that everyone doesn't get burned out and hate each other. But that's a different podcast. We're not going to go there now. Then the role of dependencies, there are really two kinds of dependencies. There's dependencies where things have to happen in a sequence, and that robs you of degrees of freedom to change your plan when oops happens. And then there are dependencies that require synchronization, where everything comes together. And if you ever heard of Andal's law, every time you have a synchronization point, the benefit of parallelization, drops a lot. Sometimes not so bad after most of it's gone, but in the beginning, one synchronization point hurts a lot. And that's kind of what broke Moore's law. Moore's law is still true, but once the way we make it true is we made more and more cores until we couldn't do it on one more core. Moore's law was perfect. Now we're doing Moore's law, but we're cheating because we're making cores, and the cores have to talk to each other, and now it's Amdahl's law. So even though Moore's law is still true, the performance gains are starting to obey Amdahl's law more than not. But that's a different podcast. So anyway, so what happens then is, if you can get how long things take, the probability of mistakes, and you can come up with proxies and models, you can then do your bond arithmetic and say, if we don't isolate our, really get strong separation of concerns, then everyone has to understand the whole monolith. It takes longer. It's easy to make mistakes. And it's a human connection between what the developers and the engineers have to do and the testers have to do, and how it's going to affect the business case, assuming they made a business case that the product owner or the senior executives are using to justify the investment. So somehow you have to make this short, compact, and understandable, and not talk about separation of concerns, because that's very abstract, and an executive who's in a hurry and don't have time to understand, just tell me what it means, right? It means it'll take longer, we'll make more mistakes, and everything else. Get better developers, etc.
Right.
John, I heard you say something in there. I want to, earlier in this conversation, you said, well, what is tech debt?
Mm-hmm.
And then here you were talking about translating things to financial benefit. And the biggest risk to financial benefit is delays. And delays are caused by, for instance, by complexity, can yield delays. And so is it correct to say, like, actually what the definition of tech debt is aspects of your software which add the potential for delays in your project?
Yes, and if I may insert, it turns out when you do the modeling, delays hurt, but incomplete features hurt more,
Mhm.
because delays, you will get your cash flows just later than you liked, but if you justified a project based on a feature and that feature doesn't get implemented, that cash flow never is realized, and
Right.
that turns out to hurt more.
And I think you described it, John, as those things that either create delays or um, increase the probability of you not being able to deliver your commitments.
That's correct.
And I would say, like, missing core functionality or misunderstanding the problem space. You could do that very quickly. You maybe aren't delayed in delivering to the market the product that fails to meet the market's needs, and that's just as catastrophic, if not more catastrophic.
Yeah. And there's a second order effect, which is if the delay is too long. Remember, we talked about software depreciation as it doesn't get out while it's still relevant. Too many delays means that there's less relevant, unrequited relevance or to be acquired. So there's actually a is it still worth doing consequence that's even farther out in the future, depending on how long that delay is.
In this bond
Yeah.
model, there's actually another part too. So we talked about delays, which can slow your returns. We can talk about incompleteness, which causes the returns to never um, occur. I would call that 2 and 3, and then there's 1, which is complexity, which just makes delivering the returns in the first place slow. Takes you a long time. You talked earlier about projects that might take 18 or 24 or 36 months. Maybe if those systems weren't so complex, they would only take 6 or 8 or 12 months. There's kind of like essentially
Mhm.
tech debt boiled. If I'm understanding this tech debt, going back to the definition question and using it in the bond context, tech debt is things that make it slower, things that make the schedule have variance, and things that actually prevent delivery.
Mhm.
Oh, it's just that easy.
Yeah.
Understanding it, the tricky part gets to, how do we help people just avoid a little or as much of that as we can, right? And if you can't get them to understand it, then it's even harder.
I
You
think,
have to you can set up guardrails and how your process works, but then you're constraining creativity and all of those things.
yeah, the biggest challenge that I've seen, John, and even in relatively young companies, that their software is maybe not even a year old, is how to unwind it, right? And on twofold. One, technically, how to unwind it? Like, how do we actually do this? And then, and I should be more precise than that. Often these are software systems that you need to continue to operate, right? You could go rewrite something from scratch, but so how do you unwind it sort of iteratively while your software system is running? And then also, how do you make the case for investing in unwinding it?
That's the hard part. I actually think you can unwind just about anything, but you have to make an investment for which there's no apparent return.
Mm.
Yeah.
It's the refactoring
Refactoring.
challenge.
Yeah.
And Brad, I didn't mean to speak over you before. Did you want to say something? I apologize.
No, no. No, I was just agreeing. I think that this the refactoring challenge is, I think, a very that to me, our business owners, when you say, look, this code exists and it has complexity. We have evidence that shows that this complexity has slowed us down on past projects. That has put our, bond model return at risk. And we would now like to make this investment to address this complexity in this component. And I have to make a bet that I'm going to be challenged by that complexity. And so it's difficult, I think, to make that case to the business owner, say, well, this has hurt us in the past. We're sure you're going to ask for improvements in this area. We would like to make the investment to make those future improvements easier, more predictable, less complex.
Yeah.
And that seems like a hard sell often.
And it's often even harder than it should be because of behavioral aspects, like the person who wrote the software now has to admit that it needs to be refactored, and my software is perfect.
Right.
So that's happened more than once, at least in my career.
I also think it's interesting. I love how you said we got to agree on what the definition of technical debt is. Like, to me, that's really important. And I guess I'm kind of curious. I have noticed. I'll share an example of the developer, the individual developer who likes to bring forward, hey, this is technical debt and it's getting in my way. And I've certainly seen cases where it's not really technical debt. It's not actually necessarily slowing them down, but it's just a preference that they want to refactor it.
Hmm.
And I'm curious, and that to me, if those slip through to the business owners, and the business owners later say, well, gosh, last year you told me it was technical debt and we authorized the refactoring, and now here it is a year later and you're telling me you need to refactor the refactor. Like,
Yeah,
you lose trust, you lose
absolutely,
credibility.
absolutely. That's a tough one. I don't have a, the you're damned if you do and you're damned if you don't. If do the cold rational thing or say write a business case and they can't, then it's not fun to work there, and I'm going to find a place that appreciates me more. And if you do, then the scenario that you just shared is a clear and present risk.
So I'm going to go out on a limb. I'm going to make an assertion, a kind of a bold assertion, and see what both of you think about it. Here's what it is. I'm going to say there is only one kind of tech debt that matters. There's lots of kind of debt, lots of things that might slow you down or create variance or cause something not to be delivered. But ultimately, there's only one kind. One type is orders of magnitude more costly than the others, and it's this tight coupling.
Let me think about that.
Well, just think of it the other way. If you had a very well-designed modular system that was nicely encapsulated, that it was easy, had nice contracts between the different parts, was easy for someone to reason about the part that they were about to change, so they didn't have to think about and worry about the unintended consequences necessarily of their changes.
So posit me this, Batman. If in the extent, this is hypothetical because I think microservices are good, but in the bad old days, we just had SOA, service-oriented
Mhm.
architecture. The semantics of the services was very coarse. They did a lot of things, and there was abstraction leakage, and we said that was bad. And then we had to manage the abstraction leakage. So we made them smaller and smaller and smaller and smaller. So let's do what math guys call a limit analysis, and they get really, really tiny.
Mhm.
So now you've got this ginormous inventory of microservices, and you've incurred, and each one is very independent, like one's for the left nostril, one's for the right nostril, etc. And and now you have to keep track of them all.
Yeah.
And so now you've incurred this overhead problem of managing a namespace of micro services, and then you have to introduce things like brokers and stuff to manage it all. So they're perfectly loosely coupled, but if you screw up the semantic boundaries and the separation. Well, like not unfair. You said the separation of concerns was strong. But maybe there could be, tribbles, too many that are close.
Yeah.
They look the same from the distance, but when you get close, they're really different. So you could conjecture that there are extremes where tight coupling is not the only problem.
Yeah.
Right, you're saying.
I also think it's.
Go ahead.
Go ahead, Scott.
Well, you're just saying if you do too much decoupling, you create a totally different problem.
Yeah, or look at Lotus Notes was completely decoupled. It was peer-to-peer asynchronous data replication, and they collided all the time. They had a thing called a replication save conflict, right? Because I guess Ozzy hadn't heard of the CAP theorem because it hadn't been published yet. But it was a pure CAP theorem thing. You could only have 2 of the 3. And he had all 3, and so he had conflicts. And then people had to get on the phone and say, when did you say? The email system used the database, and you'd get 2 emails at the same time, and you didn't know 2 copies of an email at the same time, you didn't know which one it was.
Well, I guess what I'm coming at with the coupling is it seems to me like the biggest culprit in making things difficult, resistant to change, is things that are coupled, right? I want to change this piece, but it's touching all this. No, you're shaking your head.
Well,
it's people.
yeah.
Remember, you taught Big Pile of Mud. Big Pile of Mud was a paper by a guy named Feudal, I think. I read it years ago. I think it was the University of Missouri. That paper was all about people creating the big pile of mud. It was a paper about anti-patterns, about how things that humans do under the coercive pressure that make bad software decisions, process decisions, that creates the big pile of mud. So if you're gonna, that's the root cause, according to Feudal.
Yeah.
If I'm saying his name correctly. So it's not tight coupling. That's a decision someone made. So how do you get someone to make a better decision?
Or let me challenge it even further, is even the tools that we talk about to try to prevent tight coupling, like microservices or whatever, they don't per se solve tight coupling, because tight coupling happens at the semantic level of the humans who originally thought of the solution to the problem.
Well, that is true.
Yes.
That is true for sure.
Right. And so it's just as easy to, like, oh, I'm going to use like some kind of a message broker system between my microservices. And then I accidentally stick into my messages this semantic tight coupling that is actually ruins the whole thing.
Yes.
Right. So even the technological patterns that we use to try to prevent tight coupling don't protect us from tight coupling in all cases, because it's this human error of thinking about problems that way.
It's hard. Okay, let me throw another one at you guys. We've been talking about all this bond stuff, and you maybe have found yourself in this situation. I know you have, John. And it's the question of, should I declare bankruptcy? I'm not talking about business bankruptcy, but at what point?
Technical bankruptcy.
At what point
do you write off the junk bonds? We got to just write off this junk bond.
We got to start over. We got to build a new one.
Yeah.
And there's a strong conventional wisdom in the industry, which is never, because we have so many examples of that going poorly, right? And the way I would say it is, the amount of time and money it takes for a company to get itself out of bankruptcy is longer than the executive team has patience to get there, is basically how I think about it.
Yeah, it's behavioral, right? There's a couple of things. There's a sunk cost fallacy. I put so much money in there, I'm going to keep putting money in there until the Denver airport baggage claim works. Right?
But I guess my question for you, John, is, do you think there's a point that you ever just declare bankruptcy? How would you? So I'm in a similar situation to that, where I'm working on a 15-year-old monolith. I would guess in that 15 years, 1,000 people have worked on this system easily, maybe more. And it's a mess. I mean, it's not a terrible mess, but it's like, it's got some real problems. It's slow to develop because it's such a big ball of mud. And the team knows that, and they're working to make it better. But I do get asked questions regularly. Just this week, I got asked by the head of business development for me to explain to him. He was like, tell me why we shouldn't just start over. Why that, just from my perspective, he was saying, seems like that would make more sense. We could just, put this thing on hold and just build a whole new one that'd be nice and elegant and everything.
It's human behavior again. You have to, there's a reason why Cortez burned the ships, right? You have to create this. I think you have to either get to a point of catharsis, and then you either pull out or it's fatal. I know that's a very depressing thing, but but people don't they don't want to believe it, right? Because it's throwing away what you did. You're realizing a loss instead of it maybe turning around. That's kind of the underlying cause of what people think the sunk cost fallacy is. Um, and I actually think it's sort of ethically questionable to create a crisis if there really isn't one. So, you become a hemophiliac with a pinprick. Your software just slowly bleeds. I tried driving a 68 Dodge Dart to work one day with the intent being, and this was like around 2002, so it's rusting out, right? It had that engine that ran forever, and the car fell apart around it. And I brought it in, and I parked it in this place where the executives could see it. And then during the meeting, I pulled the blind back and pointed at that car, and I go, "That's your software. I can still drive it, but." When in the rain, the puddles splashed through the holes in the floorboard because it rusted through and blah, 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 blah. I failed.
So are
Yeah.
you just saying
Didn't
it's
work.
hopeless?
It's improbable. Some people do it, but it gets down to the risk profile and the management acumen of the executives that have to make the decision, right? Because look at what they have to do. They have to, if it's a public company, they're giving earnings guidance and stuff like this. And all of a sudden we go, oh, excuse me, Bezos is one of the few people that did it. He ran his company without, it wasn't at a big loss, but he's had a long time before his investors made him, or he decided it was safe to become profitable, that let him build a lot of what he built. But most companies, you have to produce results on a quarter by quarter basis. Yeah. And taking a hiatus in those results to reinvest it to make another era of growth and peace, love, and happiness is a hard sell.
Yeah.
Because they don't want to pay for it. They want their cake and eat it too. So we get these metaphors like, oh, we're going to change the tires on the bus while it's going down the highway at 80 miles an hour. No, you're not. You're going to get spun to death and cracked on a telephone pole when if you don't stop rolling in time.
One of the companies I worked for that turned into a restart was we're going to rebuild the engine of the jet engine while we're still
I've heard
in
that
flight.
one too.
But I'll just say, like, I agree with your point, John, that it's like takes a fair amount of like real discipline to make that decision to declare bankruptcy. And then also things like second system effect tell us that it's just as likely that the second system will have other problems, right? Because human nature is to like overcommit and overbuild and over engineer, and actually end up with a worse system than the one that you were attempting to replace it with.
And if the time pressure, developers don't do well if they're at 100% capacity. It's just, I think that's an observational fact of life, which means it's not a fact. But the people that, the whole concept of flow, if you let them do good work, you get a lot of good work quickly, but you have to create those conditions, and it's very hard. One of the things I've become a fan of is the DORA metrics, because they attempt to account for that.
How do they account for that?
They explicitly assume, I don't want to misstate it out of not having read them in a couple of years, but essentially developers' emotional health affects productivity. And so some of the metrics attempt to make that assessment. And if your developers feel that, they're not understood, or they're overcommitted, or they're not allowed to do it the right way, with Brad's complication notwithstanding, which is some of them do it on an aesthetic basis rather than, this cold calculated results basis, which is fair. Remember, I keep coming back to the fact that we're all human. CTOs are human, CEOs are human, customers are humans, developers are human, and we all have different views of the world, and we can look at the same thing and have different and weigh different factors with different importances. So, it's just a hard problem. And, being honest, being able to talk about it, being able to hear each other, creating the conditions that allow that, I believe is the only way it can work. And I think the DORA metrics are a start, because they explicitly, among other things, account for the developers' satisfaction with the job, how they fit into the organization, how they're seen by their peers. And I'm not doing it justice. I'm not being precise here, but I think directionally I'm safe, but I'd have to go back and reread it.
Yeah, it's interesting. I had never really thought about how Dora also sort of relates to,
No,
I've always,
I'm wrong. It's space metrics. Dora's the DevOps metrics developed
yeah.
at Google. I said it. I've used both, and I just had a senior moment here.
Oh, well,
It's
what's funny is I was about to make
metrics.
the case that Dora would actually.
Dora does it implicitly. The space metrics are explicit about developer emotional posture.
Yes, there
They're
you go.
called the space metrics.
Satisfaction and well-being, performance, activity, communication, collaboration, and efficiency and flow. Yes, I could see how.
So like Dora, if there's a coin, Dora's on one side of the coin and space is on the other side of the coin.
Yeah, okay.
I'm sorry, you'll have to edit all that Dora stuff out.
No, we're gonna keep it in.
Yeah, it's fine.
Well, here's the thing I'm feeling right now. Typically, positivity is my coping mechanism. When faced with something that's basically insurmountable, I just say, well, I'll keep on running my head into this thing until I break through. And that's kind of how I typically feel about tech debt and these ball of mud systems. And if we keep on charging at it, it's going to figure out. But after this conversation, I'm kind of feeling a little depressed. Like I'm feeling like maybe there is no hope and we actually have to go the other way. Maybe we should embrace the ball of mud, just build crappy software. And maybe it's not crappy. Maybe it is just, maybe we're just getting entropy faster, basically. And then just figure out how to deal with it.
I think there's this middle ground. If you're extremely big ball of mud, it's not optimal, and if you're completely pure, it may not. You may not get the full return on the investment that purity requires.
Mhm.
There's got to be, and then so there's got to be this balance point where you can put up with some, but it doesn't. But if you try to make it perfect, it's just Faust and the people in the church, and it would be perfect but for the church, and then the whole thing goes to hell, literally.
You're gonna get some because you make mistakes.
But you can go back and fix them, right? If you're a perfectionist, you say, "Oh no, we can't deploy it now. We got a mistake in there, and someone might notice." And
sometimes you don't notice mistakes for years.
I had a mentor who used to say that an API is not an API unless another piece of code is calling it, right? And I think maybe there's a version of that we could say, yeah, we talked about this, that tech debt is these things that actually are complexity that can cause delays or potential failure to get the bond yield that we're expecting. But if in fact that tech debt lives in a piece of the component where that complexities that doesn't matter, then maybe that's how we find our middle ground.
Yeah, I think that's very good, because in the world could change and it could matter, but until it matters, don't sweat it.
Well, that's what I would refer to as low interest debt. It isn't costing you very much.
It's not interest. You're selling calls.
No, I understand, but in the debt framework, it's a low interest debt.
Unlikely to be called calls.
Yeah.
Yeah, it's a loan I'm not going to have to pay back.
It's right.
I'll take a few of those.
Right.
Yeah, but
then why take the loan out in the first place?
It's interesting. I feel like I spend an inordinate amount of time thinking about how to somehow break through and make it, I should say, organize, not make anything, but organize the people, meaning the engineers and the business people and the organization, get the mindset to make it so we can invest to make it easier for engineers to get stuff done. Because I just hear the same complaints over and over again. Why does it take us so long? Why does it even take us so long to get an estimate? Just the other day, this came up, and one of our principal engineers was like, why doesn't anybody just say it's just we have a complicated system and that's why it takes us a really long time to estimate this stuff. And if you want us to estimate stuff faster, let's invest in making it a less complicated system. But it comes back to some of the stuff you're saying at the very beginning about incentives and all these different things. It's just like, it's really hard to get people to want to do that. Just this week, the CEO I'm working with was like, how can we do more with less? I was like, well, we can invest in making our team more efficient, making all this code easier to work with. But that just, well, that doesn't sound like any fun. That's not sexy. I mean, she didn't say that, but that's just kind of like what I'm saying.
Yeah.
And I'm still just like, this to me feels like the epic, a challenge of our time. And I don't know how to overcome it. I thought I knew, and now we've
Well,
had this conversation, and I know less. I'm dumber because of this conversation, I think.
I don't know about
No, I think
that.
you're
I think that
sadder. Yeah, I don't think
I'm
you're
sadder.
dumber.
That's
I think
right.
you
I
might be sadder.
sadder. I think I'm gonna just take away this as we're kind of approaching probably wrapping this conversation up. I love the framing that you gave, John, of trying to think about these as, naked calls. And when we're making a choice to essentially be leveraged on a bet that if it comes
Yeah.
due, we're going to not be able to cover it, then that's a great way of framing like the tech that you
Yeah, the amount you don't do is the margin, and if you don't do it all, then it's they call them naked.
yeah, exactly.
Yeah.
And those are the ones that we need to be worried about, right? And if we can avoid those, um, but we can still sort of use the margin analogy and the bond analogy. I like both of those
Yeah.
analogies over the debt analogy.
Yeah, well, there's one last thing that since we're running out of time, I did spend 5 minutes digging through my tech debt folder, and I turned over a pearl of history that I had forgotten about. But if you want to do a deeper dive into tech debt, it turns out that the OMG has written a standard called Automated Technical Debt Measure,
Well, what is the OMG?
and the Open Group,
Hmm.
no, the Object Management
Hmm.
Group. I don't know if they still exist, but when I used something called Boca when I was at Merrill Lynch for a while, and I used that to model the business, and then I tried to basically make business API. Archimate, we have you have business APIs, business implementations, which are the process that realize those APIs, and you have applications that provide services to the process that are realized. So you have application APIs that are realized by applications, and then those applications are hosted, and now we have AWS, so you're hosting your infrastructure APIs that are realized by blinking lights somewhere in Nevada with a hydroelectric plant or a nuke. But so the OMG did this, and the document is OMD document number formal/2018-09-01. It's 100 pages long, all
Love
about
it.
measuring technical debt. So
Wow.
if you have insomnia or
We're
you
going to
care,
add this to this is definitely going to be in the show notes.
yeah,
A link to
and you
this.
care, I can send you the URL. I haven't, I have a copy, so I hope they're still around. And if not, the Wayback Machine may have it. But
No, I found it.
there's
There you go.
there's
I
your
just shared
okay.
the link to it. It's the
Put it
purpose of
under
this
your pillow, and you'll either have solved it or you'll have no more insomnia.
This is awesome. Look at this. I'm going to just read the headline on this one, Scott. The purpose of this specification is to establish a standard for automating a measure of technical debt that can be computed by source code analysis techniques, which have been implemented the CSIS quality characteristic measures.
Huh.
Gesundheit.
Exactly.
Well, John, thank you for your time today. It's been
Well,
fun.
thank you for the flattery of your interest. I'm honored.
Well, I
Namaste.
always love talking to you. You're brilliant. Was my point of view.
Yeah. It was a pleasure to meet you, John. It was a wonderful conversation.
Likewise, Brad.
And I look forward to maybe having another chance to talk with you about deep topics and deep thoughts.
Yeah, well, not being brilliant, I can have lots of opinions about lots of things. So you can be brilliant or you can be entertaining. So clearly I'm entertaining.
Two things can be true at once.
All right. Thanks, guys.
This episode of How Many CTOs Does It Take podcast was edited by Saffron Hefta-Gaub. Our theme song was AI generated by Brad. Please follow us on all the social media platforms at How Many CTOs Pod. You can find us on YouTube, LinkedIn, Instagram, Facebook, Threads, X, TikTok, and Patreon, or at our website at howmanyctospod.com. And remember to rate, review, and subscribe on the podcast platform of your choice. Thanks for listening.